Hey everyone, welcome to this explainer. We are jumping right into the code classroom today to break down the absolute foundational mechanics of Python. Because look, if you want to write truly efficient, bug-free code, we absolutely have to master exactly how Python calculates, compares, and stores data under the hood.
All right, so here's our syllabus for today's masterclass. We're going to hit 5 key building blocks: arithmetic operators, comparison operators, assignment operators, logical operators, and finally, we'll wrap the whole thing up with operator precedence.
So let's just get right into it with section 1, arithmetic operators. You know, the basic math.
You can basically think of these guys as the standard buttons on a calculator. They are designed to do all the heavy lifting for your mathematical operations inside your scripts. Now, obviously, you already know your standard addition and multiplication, but let's talk about the special Python tools we have. We've got the double slash, that's for floor division, which just completely drops the decimal. Then there's the percent sign, the modulus, which gives us the remainder. And of course, the double asterisks for exponentiation, or, raising numbers to a power. And actually, thinking about this in action is pretty cool. Notice how the modulus operator handles variables. If it takes 10 and divides it by 3, it totally ignores the quotient. It strictly returns that remainder of 1. Honestly, modulus is one of those incredibly useful tools you'll constantly reach for in your programming kit.
Okay, moving right along to section 2, comparison operators. This is how we evaluate logic. Because, once you have data in your script, you're going to need to compare it, right? Picture an old-school balance scale. Python basically takes data, puts it on both sides of the scale, and weighs them to figure out the relational logic. Are they exactly equal? Is one side heavier or greater than the other? So when we ask Python, hey, is our x variable 10 greater than our y variable 5? It gives us a definitive true. But if we flip that and check if 10 is less than 5, boom, it outputs false. Python is super strict here. It evaluates all these comparisons down to simple Boolean values, no gray area. All right, section 3. Once we calculate or compare all this data, we need a safe place to actually put it, right? Enter assignment operators. It helps to just think of variables as containers, or little boxes, and that single equal sign, that's your primary assignment operator. It literally represents the physical action of taking whatever value is on the right side and packing it securely into that variable container on the left. But here's the fun part. You don't have to stick to just a plain equal sign. Python gives us these awesome compound operators, like plus equals or multiply equals. These let you do the math and store the updated value all in one smooth step. So if you run a plus equals b, it grabs our a variable of 10, adds 5 to it, and instantly updates that same container to hold 15. It's just so much cleaner. Okay, time to step up the complexity a bit with section 4, logical operators. This is all about combining conditions. Think of these kind of like traffic lights at a crazy busy intersection. These operators, specifically and, or, and not, they direct the entire flow of your program's logic based on multiple converging conditions. And remember, no matter how insanely complex your logic gets with dozens of variables, these expressions always boil down to just 2 binary results for your code's traffic flow. You either get a green light for true or a red light for false. Think about the AND operator for a second. For this to work, both variable x and variable y absolutely must be true for the overall result to be true. If x is true but y is false, it just outputs false. The OR operator, though, way more forgiving. True or false evaluates to true, simply because it only needs one single condition to be met to give you that green light. We have covered a ton of ground, but we need to tackle section 5, operator precedence, basically the execution order. Because what actually happens when we mix all of these different operators into one massive, chaotic line of code? Well, spoiler alert, chaos doesn't ensue. And that's because Python follows a very strict staircase of execution. It always starts way up at the top step with parentheses, then it steps down to exponentiation. Next, it handles your multiplication, division, and modulus, and finally, way down at the bottom of the pyramid, it computes the basic addition and subtraction. So you really have to remember that Python doesn't just read left to right like a book. Imagine this equation: 4 times 3 plus 10 divided by 2 minus 11 modulus 3. Mimicking its internal processing, Python groups the highest precedence stuff first. 4 times 3 is 12. 10 divided by 2 is 5.
11 modulus 3 is 2, and only then does it execute the plus and minus signs, perfectly solving the whole equation to get 15.
Now, if you ever want to hijack that default order, parentheses are absolutely your best friend. For example, by just adding parentheses around 3 plus 2, we completely override those normal multiplication first rules. We're literally forcing Python to calculate 5 times 5 to get 25. Parentheses let you control exactly how and when your code executes. And just like that, you've got the foundational mechanics of Python syntax down. Now that we've uncovered these essential building blocks and the strict rules of execution inside the code classroom, the real question is, how are you going to combine these operators to write your very first dynamic script? Keep experimenting, keep toting, and I will see you in the next explainer.